Good afternoon, everyone. My name is Azmeer. So we'll be looking at software engineering methods from today. Let me switch into the presentation. Before I do that, I also have a few questions to ask and clarify. Okay, so I hope you can see the slides, no problem. All good? So what I'll do is I'll take you through the presentation now, and we'll discuss the outline and what we are planning to do today with this unit. And then we will look at how we can go forward with this, right? So this is software engineering methods. So let's look at the outline and aim as to what we're trying to cover in this one, right? And that is where I also need some clarification from you to see whether you have done certain things so that I don't need to repeat the same topics and subjects. So I can then put my focus on the areas where you are not covered. Okay. Now, talking of myself a little bit, I joined the academic field after working for an industry for a long time, building software, the multimedia application and things like that. And then I ran something called a business incubator for a while, helping companies to get up and running, joining the industry. And then I joined the academia. So I've been running a multimedia department for a while, and then I shifted to the IT faculty, where I'm currently heading the DATE program, that is the degree in applied IT. I'm also delivering a few subjects for other faculties also. Right, so if you look at the aim of this unit, we are looking at application principles, rather applying the principles of software engineering. One big reason is the principles or the techniques that we learn on building small time software, like say, we call it MVP, minimum viable product, or for the valuation of certain ideas. That's one thing, you can do that, no problem. But when it comes to building large scale software, industrial strength kind of software, there are certain principles that we need to adhere to, right? So those are some of the things that we'll be discussing in this unit. So we are looking at, as it says, to apply software engineering principles and practices for designing, testing quality software for scientific and business applications, and also adapting emerging ICT innovative ideas, and also solve social problems and analyze real world problems. So that's a lot, right? So a lot of things are there, a lot of expectation is there in the aim. Of course, we can't cover everything in one unit. So let's see how we can break it down into some subtopics. Okay. Now, prerequisite, meaning what are the units you need to do before joining this unit? There is nothing, none. So you can start this without doing any other unit. But I would suggest having some experience in software development previously, programming, project management, things like that would be really helpful in this unit. So if you look at the assessments, they are broken down into 3 areas. So you have continuous assessments that will give you 20%. And then there is a mid-semester exam that will give you another 20%. And then you have the final exam that gives you 60%. So that's the design of the assessments. And if you look at the learning outcome, as in what is expectation after you complete this unit, there are 4. Use design patterns, design software according to object-oriented methodology. So we are looking at design patterns. That itself is a one big unit. And then there is object-oriented principles and coding. That's another big area. And also we are looking at project management, another big area, in fact. Then we have requirement gathering, things like UML and, noting down what the customer want in a way the developers can understand. Also test planning, what is testing, and then under that, there are so many other things like SQA, we call it, software quality assurance, where we look into code inspection, configuration management, stuff like that. And then comes the procedure of validation, right? Validation as in the business analyst captures some information from the marketing team and the client, and then the developers must be communicated with this information. So what are the tools available to do that? Yeah. And also software code management. Now, you might be using something like a GitHub or something. There are various concepts there. There are branches. Then there is something called code quality management, code reviews. Then there is CI/CD systems where you automate publishing into your server. So stuff like that. So how do you manage a large project? Okay. And then project management itself is a big deal. So we are looking at requirement specification, architectural design, because your architecture must be solid before you get into any design or coding at all. So just like building a house, the house must be designed first in a architecturally a pattern, right? So only then house will withstand floods or wind or whatever it may be. So it is also same when it comes to building software. So we're looking at designing the software very well in a robust manner so that it'll withstand traffic or hacking or anything else that can happen in the future, right? And then the last one is on the SQA, that is software quality assurance and cost management, right? The cost management is actually part of the project management, but we also look at some of those concepts and see how that is helping us in building large-scale software. So these are the four, I would say, broad learning outcomes in this unit. And I also have an outline as to how we manage the learning outcomes. Yeah. So there are 5 areas that we'll be looking at. I need to clarify these things with you, like I said. So starting off with introduction to software engineering. Then we are looking at requirement analysis and specs. Then we are looking at planning the software project, mostly on the project management side. And then function-oriented design. So we are looking at, because that's sort of the way we do. If you look at the earlier way of building software, we had something called the waterfall method, where you do one step, you go to the next step, and the next step, and the next step. But that's not very dynamic, meaning so after you build something, when you go to the customer might come back and say, look, I wanted this change or the other change, or I don't want this, things like that. So we have a dynamic way of building software now. It's called the agile method, where you generally have like a 2-week of work called a sprint. And then you take that, show it to the customer, sit down and then discuss as to what are the changes required or how to plan the next sprint. And then you go on like that. So that's project management practice when it comes to software engineering. So there are also various other things like unit testing, code reading, statistics, also important as to see a number of bugs, bug tracking, for example, estimation of features. So there are a lot of stuff there we'll be covering under software engineering. Now, why all these things are important, right? Lots of different things, as you can see. It's a wide area of things. So here's the bottom line. Software engineering principles provide guidelines and best practices for designing, developing, maintaining software system. So it's not only design, not only development, it is also about maintaining. Because when you build the software and give it to the customer, things can go wrong. New staff might come in. They may have new changes. Let's say the government might change the taxation, or they might want to improve the fees. they might add new products to their range. So they should be able to do certain things themselves. If they can't do that, they will need to come back to us, the developers, and we should have a mechanism to incorporate the changes and then come back to them. Of course, we will charge them, right? We will charge them for the changes and upgrading and training and all that. But the process of maintaining the code is very, very important. So if you can't find where the source code is, if you don't have a maintenance system, if you don't have documentation, if you don't have test plans, that's a serious problem, right? You will not be able to maintain the code. So these engineering principles help us do these things, okay? Manage these things. So our focus areas are generally in three, right? Of course, I will expand this into so many subsections, but generally speaking, we are looking at three areas. One is the SDLC, that is software development lifecycle. So starting from requirement capturing to planning to architecturing to architecture and planning, and then comes the development, SQA, that is quality assurance. Then we have testing, and then we have deployment, right? So lots of small things are there under this cycle. Now we also go down to software development cycle, where how to manage source code, how to have like multiple teams accessing the same code base. There can be conflicts. How do you handle conflicts? And then how do you go back? It's called rollback to various previous versions. How do you maintain quality of the source code and things like that. And then comes the software architecture. This is where we are looking at design patterns, architectural guidelines, a lot of things again under that. Yeah. But all in all, in a higher level, these are the three things we will be discussing under this unit. Now we expand it further, right? If you look at the kind of software we are using and we will be building, we won't be building all these things, but the software that we are using in a day, right? You can categorize into, various forms of this. There are systems like a foundation of things where you use the system in order to use the others, like operating system as an example. So you need, let's say, Mac OS or an Android on your phone or iOS on your Apple phone or Windows for that matter. For you need that as a foundation for you to use other applications. So right now I'm using Zoom. I'm using PowerPoint in order to do the presentation. So these are tools I'm using in order to do this work today, right? And then we have standalone applications like mobile apps, desktop apps, things like that. Even you can say web-based app also can be sort of a standalone, although it is coming from a web-based application. Then there are business applications, pretty complex stuff, right? They may be not just one application, they may be multiple applications working together in an integrated fashion. So examples like ERP, Enterprise Resource Planning Software, CRM, Customer Relationship Management Software, complex accounting system where you sort of bring in multiple departments to the picture, right? And then we have database systems. They are based on their own. So things like Oracle, MySQL, Microsoft SQL Server, IBM DB2, stuff like that. They're very complex systems. And they are specialized in, even MongoDB as an example. They are specialized in managing large quantum of data, in the sense like storage, retrieval, processing, searching, all that is part of the database management systems. And then we have specialist machines. Like say, for example, if you go to a petrol station, they have a little portable gadget to read your card and also give you a printout, right? Or if you go to a supermarket, they might have gadgets where, again, software driven. It might be water sprayers. It might be to control the pricing of the shelves, things like that. Those are all combination of things. There are hardware, software, there are some other gadgets like motors and whatnot. So mechatronics come under that. But as I said, our focus is on software, right? There are types of software available out there. We talk about building the software under all these things. Building a software to control a gadget, building a software for a system like a operating system, or building a standalone desktop application. So the process of doing that is pretty much the same because it's all engineering, right? Very similar to building a bridge or building a house. It's the same thing, right? Now, there are some relationships under software engineering, if you look closely, on various sciences, right? Now, this is where some people get confused. Okay, are we doing computer science? What is the difference between computer science and software engineering? Are they same? What about systems engineering? Is it different to software engineering? So I thought maybe I'll clarify that. So computer science focuses on how computers work and how to use that knowledge into solving practical problems. Okay, so how to use the computers and then how to use that to solve problems. So the science of computers, or the principles that we are talking about in the computer science, generally cannot be used to discuss complex software applications, right? There is a limitation on computer science. So we need to know computer science, but we can't build large-scale computer application only knowing computer science, right? We need other things also. And if you look at the second one, systems engineering, it focuses on systems, right? Including software, hardware, processes, people. It's essentially the overall structure of building something, right? Systems engineering. The last one is the software engineering, where we are looking at focus on primarily on engineering of particular software components. Now, this is our focus, the last one, right? So either we are building an application or we are building a part for an application. So maybe a library or a component that will be plugged into another large-scale application. So these are some of the areas that you will see in the market, right? Computer science, systems engineering, software engineering. So if you're confused about the differences, okay, here we are, right? And our focus will be the last one, software engineering. So we're looking at how to engineer and build something with the principles of software engineering, right? So that's our focus. Now, before we move out, one very important thing, right? It says in this industry, creativity is prized above all else, and the art of the craft must be honored. Now, what does that mean? Anyone can build software, right? Because programming languages are freely available. You don't have to purchase languages. Now, there was a time where you had to buy software language in order to develop it. But now it's pretty much free. Java is free, C# is free, Python is free, PHP free. Pretty much all the languages are free now. And it also doesn't mean that anybody who can learn the language can build robust software, right? Whoever building, it's like this. Now, if you have a creative idea and you don't know software engineering, no problem. You can learn a few tricks and then build the software. But when it comes to scaling, like, okay, can my software be used by 1 million people at the same time, right? At the same time, whether it is a desktop or a online version, how do you scale that? Or if your software is like a music streaming or something like YouTube where you are streaming video, how do you handle 10,000 connection at the same time coming to the server, right? Versus a small time accounting package where are 5 people, 10 people using at the same time. So these are some of the challenges we will have when it comes to building large scale software. So creativity, that is thinking fresh, is very, very important, right? So this is why every year you will see new software coming, new apps coming, right? When Apple launched iTunes long time ago, it was groundbreaking. Before iTunes, there is no way to purchase individual songs. Right? You have to steal, you pirate the music, or you buy the whole thing. Buy a CD which has all 20 songs of someone, where you only need one song or two songs. iTunes changed the whole game, right? So what they did was they struck a deal with the music producer or the author or the singer, and they got the high quality music on their platform. So if I'm listening using iTunes, I need to purchase iTunes monthly subscription, and of that they will pay a percentage to the musician. Good deal for everyone, right? I get high quality music as a music lover. The singer gets his portion for the music. I mean, he can decide to share it with the lyric writer, the musicians, and whatever, but he gets the money, right? If you steal, no one is getting money. And then Spotify came. When Spotify came in, that was a very creative way of doing the same thing what iTunes did, right? But no one thought Spotify can do any good because iTunes was fantastic. There is nothing more to do. So that's where the creativity is important. So Spotify thought, okay, iTunes is very good, but there is still market, there is still opportunity for any new business to start. So they came up with their app and became a multi-billion industry by now, right? Same can be said for Gmail, same can be said for YouTube. So don't think it's done and finished. There is nothing else to do. Yeah, maybe if you are creative, you can think of something else, right? Something new on this. So this is my email address. I think I will also switch to our LMS, show you what we have there. Okay. How many of you here also following my other unit, software quality assurance? Can you raise your hands? One only? Okay, two, three people. So I've shared the same books, right? Here as well. So in case if you haven't got it there, it's available here as well. I'll be adding few more additional books here because under SQA, we are looking at only software quality assurance, but these books speak in a general purpose way about software engineering plus SQA. So you can use the same book for both units, okay? Especially this one is a Bible, Software Engineering by Somerville, and other two are also very interesting books. So I've shared the book here. And if you notice, yesterday after the lesson, I've uploaded the video recording. So today also you will get a recording of what we discussed today. And I'll be updating this unit as you move forward. And this one, the announcement, is basically a forum where we can discuss things. So please use the forum to post your questions, right? So me or somebody else can always answer the question if you have any, right? So that's our LMS. Oh, by the way, so this is a 3-credit unit, core unit as well. I think I discussed about the LOs and summaries here also, by the way.